Hi, everyone. Uh, my name is Fabricio Cravo, and I'm working with Professor Stephanie Noble here at Northeastern University, and I'm going to present our power calculator. So, what is our motivation for research? Well, first of all, there's a reproducibility crisis in fMRI. So, essentially, it's really hard to get consistent results throughout uh, uh, several experiments we're trying to measure the same thing and we're working with same conditions. And what's the main cause for this? Well, the main cause is the lack of statistical power. So the power is the probability of detecting a true effect. Well, when there's a true effect in your experiment, you have a probability of detecting it, and that's basically given by statistical power. And unfortunately, with fMRI data, due to low signal to noise levels, power tends to be really low, which leads us to this tip of the iceberg effect, where you're only detecting the strongest possible effects, the tip of the iceberg. However, there's a lot of underlying effects under the water that can't be seen due to high noise levels. And as an example, or as a greater call for the motivation, well, if you have 10%, if you have an effect with 10% of power, it's only going to be detected one of 10 experiments. So having to repeat an experiment 10 times just to detect an event is not it's not really a good idea, especially considering the costs of fMRI experiments. What is our okay, so what is our planned interface for this power calculator? Well, as it was said in the title, it's a web-based interface. So you would be able to access to a URL. And the idea was that you would input your experimental conditions and you would have a power estimation, or you input conditions which are closest to the experiment that you're planning on working on. And what is their strategy for the power calculator? Well, we're going to leverage data sets which have a high amount of subjects, and we're going to use all those subjects in those data sets to detect the true effect location. Then we take small subsamples of less subjects from the data sets, and we use those subsamples to simulate experimental conditions and statistical methods that would be used in those experimental conditions. Once those experimental conditions are simulated, we see how many of those experiments were able to detect one of our estimated true effects. And with the ratio times the true effects are detected, we have an estimation of power. Our power calculator uses the NBS tool, which is available in the QR code in the QR code supplied. So what is our planned impact of our power calculator? Well, first we want to improve power. We want researchers to be able to know the best statistical method to detect the effects that they're interested on. So different effects have different power values, and if a method is more likely to detect your effect than another method, well, then you would like to have this information. And the other reason is to estimate sample sizes. So usually the price for a subject in fMRI analysis can be quite bothersome. So having a good estimation on how much subjects you're going to need to detect the effect that you're interested on or explaining a certain phenomenon in the brain, that could really help you with costs, especially if you, for some reason, might have more subjects that you actually needed. So the power calculator is currently a work in progress, and you can accompany this you can accompany the process in the following GitHub that's supplied. With that, I would like you to thank you for listening to this talk.